In this week's video, we will be performing the classic grade school science experiment, ice cream in 5 minutes. Classic for its simplicity, the wealth of scientific knowledge you can incorporate, and its deliciousness. And as always, the associated worksheet that is free to download to give your kids as a post-video assessment will be posted to our website soon. So let's get started. Hey everyone, in this week's video we're going to learn all about the states of matter and the phase changes that occur between them, all by making ice cream.
From scratch.
In just 5 minutes.
Without an ice cream maker or a freezer.
That's right, all you're going to need is some milk, cream, vanilla, salt, sugar, and some Ziploc bags.
Did Ziplock say yes to the sponsorship? Do we finally have our first sponsor?
Well... Hello Ziplock, this is the Homeschool Science Club, and we're going to be using some of your products in our next video, and I thought you might be interested in sponsoring our video. What do you mean, how many subscribers do we have? Hello? That was rude. They said they'd think about it.
They said no.
They said no. The first thing you're going to want to do is gather the ingredients that you probably already have around the house. The materials you're going to need are 1/2 cup of whole milk, 1/2 cup of whipping cream, 1/2 teaspoon of vanilla extract, 1/2 to 3/4 cup of salt, 1/4 cup of sugar. Additionally, you're going to need 2 Ziploc bags, one large one and one medium-sized one, and along with a good amount of ice from your freezer. The first step is to take 1 cup of milk and pour it into your medium-sized Ziploc bag. And since we're making ice cream, you're going to want to use whole milk, because who really cares about calories when it's for science? One very important tip to remember is after each step, be sure and seal the Ziploc bag pretty firmly, just in case it accidentally gets knocked over. You won't spill everything and have to start over. Now you're going to repeat the same step, only using a cup of whipping cream. It also gets poured into your medium Ziploc bag combined with your milk. And now it's time for my son's favorite ingredient, the sugar. For this step, take 1/2 cup of sugar and put it into your medium Ziploc bag, combining it with your milk and your cream mixture. And you may want to take a spoon and mix it around to make sure the sugar is nice and dissolved before moving on to the next step. This is all followed by adding 1/2 teaspoon of vanilla extract to add that added bit of deliciousness. Now, phase 1 of our experiment is officially complete, and for scientific purposes, we wanted to take the temperature reading of our cream mixture. You can see here that our cream solution that we just made measured 62 degrees Fahrenheit. We'll talk more about that and its importance in the second part of the video when we're discussing the science behind all of this. Next, it's time to take your large Ziploc bag and fill it about halfway full with ice cubes. And again, for scientific purposes, we took a temperature reading of our bag of ice. And giving our kitchen meat thermometer a 1 degree margin of error, you can see that it quickly got down to essentially 32 degrees Fahrenheit, the freezing point of water. Next is the most important step of the process, and it's the reason this experiment all total only takes about 5 minutes after you get everything together. Now, the clip that you're watching now, I haven't edited in any way for time or made any cuts to it. I did that so you can see how impressive the science really is. My daughter just got finished adding the salt to her ice bag. She gives it a nice tight seal, and then she shakes it around for just a few seconds. And coming up, she's going to put the thermometer in the ice bag, and you're going to see how quickly the science takes over. Keep in mind, we just measured our bag of ice at 33 degrees Fahrenheit. We put the salt in, it's only been a few seconds later, and look at our temperature gauge. Pretty rapidly and impressively, you can see the temperature of our ice salt bag solution drops to 19 degrees in a super short amount of time. From 33 degrees to 19 degrees just by adding salt. That's science, and that's pretty cool. And again, we're going to talk about that more in depth in a few moments. Now, the only thing left to do is to take your medium-sized bag and place it in your large bag of ice. Be sure and seal both bags nice and tight and start shaking. Keep in mind that holding something that is 19 degrees Fahrenheit is pretty cold, so if you have some gloves, they'll go a long way. And my son was being rather gentle with his shaking. The more rigorous you shake it, the more creamy your ice cream will be. After 5 minutes of shaking, it's time to see and hopefully taste what we've created. And you can now see what was once a creamy liquid solution has definitely hardened into ice cream. With only a few minutes required to mix the ingredients and about 5 minutes required to shake the whole cocktail together, using our knowledge of science, we went from liquid milk to ice cream without a freezer or an ice cream maker in just a matter of minutes. It's a great exercise. Tastes good? Tastes like ice cream? And while vanilla ice cream in and of itself is delicious, I mean, come on, we have to spruce it up a little bit. In the name of science education, of course. So what exactly is going on here, and what does making ice cream have to do with science? To answer that question, we need to talk a little bit about the basics, and we have to have some knowledge about the states of matter. There are 4 naturally occurring states of matter: solids, liquids, gases, and plasma. And while plasma just might be the most abundant state of matter in the universe, it's not that common here on Earth, so we will discuss it separately in another video. For our example going forward, let's say this single blue dot represents a molecule of water. And let's pretend we have a lot of blue dots. When water molecules are in its liquid form, they have a lot of energy and they move around a lot. The energy in those water molecules causing the movement is usually provided by heat. But if we were to start to take that heat away, the water molecules would slow down, come together, and ultimately form an ice cube. Just like the ice cubes being dumped into this pan. The ice cubes, of course, are cold. Its water molecules that make up the ice are not moving that much, and therefore the ice maintains its shape. Now, if we were to add heat to our ice cubes, at that point, the energy from the heat would cause our water molecules to start moving around more. They would move around faster and faster and ultimately spread apart, causing them to lose its shape as a solid, and that's what makes it a liquid. As you can see in our kitchen example, when I turn on the oven, the heat begins to warm up the pot. In our example, the water molecules begin to move around more, creating a liquid, and that's exactly as you can see what is happening here. The ice molecules, when they are cold, don't have a lot of energy and they maintain their shape, but as they begin to heat up, they move around more, spread apart more, and our ice is melting and now becoming a liquid and taking the shape of whatever container you put it in. And as you continue to give it more heat, the liquid molecules will get more energy and increasingly move farther apart, evaporating into a gas, as you can clearly see here with our boiling water. It's time to refamiliarize ourselves with the term phase change. A phase change is what happens when matter changes from one state to another. For example, when a solid melts to a liquid, that's a phase change. When a liquid evaporates to a gas, that's a phase change. And each phase change has a specific name. We've mentioned a few of these before, but for review, when matter changes phase from a solid to a liquid, it's called melting. From a liquid to a gas is vaporization. A gas changing to a liquid is called condensation. And liquid matter to solid matter is called freezing. Now, less commonly, for example, in the case of dry ice, solid can go straight to gas, and gaseous matter can go straight to solid matter, bypassing liquid altogether. When solid matter goes straight to gas, that's called sublimation, and when gas matter goes straight to solid matter, skipping liquid, that's called deposition. As a quick aside, a few months ago we did a really fun experiment where we showed exactly what happens to the temperature during a phase change. So you should check that video out. I'll leave it in the description right here. So what does all of this have to do with our ice cream experiment? 2 phase changes occur during the experiment. When we place the salt on top of our ice in the bag, it lowers the freezing point of our ice, making it want to melt. But as we discussed earlier, it takes energy or heat for that phase change to occur. So where does that energy come from? Well, it comes from our cream solution. Remember when our cream solution measured about 60 degrees? While that may seem pretty cold to us, compared to our salt and ice solution, that's pretty warm. So for our ice to melt, it actually takes the heat from the cream solution, causing the cream solution to drop in temperature. As that temperature drops, its molecules begin to slow down, it begins to freeze, and there we have ice cream. 2 phase changes, melting ice and freezing cream. And in the end, it's delicious ice cream, and we've learned about states of matter and the phase changes that occur between them. That's it for this week's video. We hope you enjoyed the ice cream.
And the science we sprinkled in.
Don't forget to subscribe to the channel if you haven't already, and we'll see you next week.
Bye, everyone.